Hello, this is Kenneth Wong, contributing editor for Desktop Engineering magazine. If you follow some of the mergers and acquisitions in the industry, you might recall that last Christmas, while you and I were busy buying stocking stuffers, Autodesk went out and bought an analysis software company called Algor. Well, last week, Autodesk Algor Simulation 2010 was released, marking the debut of Algor under the Autodesk brand. To get a taste of how Algor Simulation works, you can download and try out ALGOR DesignCheck, a free first-pass analysis software. That means the product is targeted at engineers who want to do a simple, quick analysis of their part to understand where and how it might fail under stress. This is not meant for FEA specialists who would do a thorough analysis on thermal, flow, fluid dynamics, and others of a design. For that, you'll need Algor Simulation, the full product. But for what it's worth, let's take a look at the free DesignCheck application. First, I needed a part to try out in the analysis program. So what I did was went to traceparts.com, then downloaded a standard piston cleavers from Norgren as an IGES file. And here's the part in Algor DesignCheck. To begin with, I'm just going to mesh the part. Now that the meshed part is ready, I'll identify a surface as a fixed corner. I did that simply by picking the surface selection tool, then the rectangle selection command. And I also did the same thing on the opposite side. You can now see that I've applied surface conditions by the little arrows that now appear on both sides of this little bar. Now I'm going to specify that while this part is fixed in such a way, a force of 50 Newton is coming to hit its bottom surface. Well, yes, I realize this is much too great a force, something a piston cleavers might not be compelled to endure, but if I pick a smaller force, I won't have much to show you when the analysis is over now, will I? The next thing to do is to define the materials of the part. Let's just pick iron, and I'm just going to accept the default values as it is stated. Well, the part is now ready for analysis, so let's hit it, maestro. Here now is the analysis result. As you can see, you can go through each of the category to figure out, for instance, what the displacement looks like, what the deformation looks like, and so on. Now, if you need to probe the maximum impact on the part, you can pick this arrow and it'll show you where it is. You can also select this arrow to specifically point at an area on the part to obtain the numeric values of the stress that is applied there. The deformation is available in an animation form, showing you exactly how the warping occurs, and if you would like, you can export that animation as a Windows media file. Of the three tabs, the last tab gives you access to a report. It is a report that you can customize with your own logo and your name and your reviewer's signature. After that, that report can be published as Word, PDF, or an HTML format, among others. DesignCheck, as I found out, is very simple to use and easy to understand. It's just the right kind of tool for non-specialist engineers who want to double-check their parts before sending it off to manufacturing. I'll soon be updating Virtual Desktop blog with a post about Algor Simulation, along with the pricing info, so come check it out. Till next time, this is Kenneth Wong for Desktop Engineering, wishing you a stress-free day.